have a hollow sphere of radius r, and after integration at a distance of smaller we want to find the electric field. Obviously we know the electric field should be away from the center of the hollow sphere, and after integration, even before integration, outside the brackets we have E net is equal to KQ divided by 4 small r square into capital R. Yeah, tell me.
Okay.
Z plus.
Writing capital R square.
Correct. That's what I'm saying. That there is no capital R square in the denominator. There is capital R in the denominator.
Okay. That will be KQ by small r square.
KQ by 4 small r square capital R into Z plus R square minus small r square divided by Z. For this, here we have two cases. We said case 1 is inside the sphere, right?
Yes, sir.
Inside the sphere. So what is the condition for inside the sphere? Suppose I took this point. I said this is the point where we have to find the electric field inside the sphere. That means this distance will now become r, smaller, right? Yes. So what will be the limits for my loop as theta varies? Limits for my z as theta varies from r plus r to r minus, right?
Yes.
So inside the sphere I have E net is equal to, here we have to specify the limits. So for each case the limits will vary. So KQ by 4 small r square capital R. So this is the thing, okay? Instead of capital R square, we need to have capital R. Okay, so while you're doing the derivation right from the beginning, start doing it and see where we have mistakenly written R square is what I'm saying.
Yes.
While deriving it again, see where mistakenly have we taken it as capital R squares. It has to come as capital R. It will come as capital R actually. Okay?
Yes, sir.
Z plus R square minus R square divided by Z. And for inside, we are taking the limits as small r plus capital R to
small r minus. No, that was capital R minus. Yes, sir.
From left to right also you can start. The distances basically are these distances. So my element starts from, let's say, left to right or right to left. It's our wish. Eventually we are covering. Actually, I'm going to take it from right to left because I took theta from right to left. Theta anti-clockwise I took in the figure, this angle theta.
Yes,
so I'm taking it from right to left. So I'm taking the lower limit as small r plus capital R. This distance, which is small r plus capital R. And this distance is going to be capital R minus small r. Total radius minus the small r. Small r plus capital R to capital R minus small r. Now substitution of limits. So I will write this KQ by 4 small r square into capital R aside. Upper limit minus lower limit, right?
Yes, sir.
So first term is r minus small r minus of r plus small r, correct?
Yes, sir.
Plus upper limit minus lower limit. So I have r square minus small r square divided by upper limit is r minus r minus r square minus r square divided by r plus r. So this is r minus r is 0 and minus r minus r. I think this is coming as minus 2r.
Yes, sir.
Plus a square minus b square divided by a minus b is a plus b.
R plus R minus of R
minus of
R minus
a square minus b square divided by a plus b is a minus b.
Yes.
So how much are we getting here? Capital R minus capital R will cancel, and smaller plus smaller will be 2 smaller minus 2 smaller, which is 0.
Yes, sir.
And I told you to write a statement over there and put 2 star marks.
Field inside the hollow sphere is always 0.
Is always 0. Anywhere inside the hollow sphere, electric field is 0.
Yes, sir.
Clear?
Yes, sir.
Okay. Next case is outside the hollow sphere. What are the limits for outside hollow sphere?
R minus R to R plus
Which R minus which R?
R. Yes, sir.
Yeah, tell me.
It's R minus capital R to R plus R.
Which R minus? Okay, R minus.
Capital R.
Good. 2?
R plus R.
Good. So case 2, outside the hollow sphere, electric field, net electric field is equal to, again, kq by 4 small r square capital R. This everything will be the same. Limits will change. Now we are considering this distance as small r and the radii as capital R.
Yes,
Right?
sir.
So my first limit is going to be small r minus capital R. Okay, this is the distance outside, let's say some point P. Then the upper limit is going to be this entire distance from here to here.
Yes, sir.
So it is smaller plus capital R.
Yes,
So my
sir.
limits will start from smaller minus capital R to smaller plus capital R. Okay,
Yes, sir.
is equal to kq by 4r square into capital R in brackets. Upper limit is small r plus capital R minus lower limit small r minus capital R
Yes, sir.
plus upper limit r square minus small r square divided by, we can write this like this, minus lower limit r square minus small r square divided by small r minus. Actually, I can take this inside and have fun, right? If I take minus sign inside, automatically it will become capital R minus small r. Then it will be more easy for me. Okay. So kq by, yeah.
So you can take it there and
Yeah. So I have what over here? R minus R will cancel. So I'll have 2 capital R. Correct?
yes, sir. Yes, sir.
Plus the first one is a square minus b square by a plus
R
b.
minus R.
So capital R minus, I'll write plus over here because I'm taking minus.
It will be R plus R.
Capital R plus small r. Great. Again my minus small r plus cap small r will cancel. This entire thing is going to give me KQ by 4 small r square into capital R into, in brackets I will have 4 capital R. Will cancel each other. KQ by R square. Anywhere outside of the sphere. Right?
Yes, sir.
Is this clear?
Yes.
Hi guys, I hope you enjoyed the session. If you think this video was useful, don't forget to like, share and subscribe to my channel. Also, I'll be waiting for your comments in the comment section. See you in the next video.